Harnessing heat, exploring different heat engines.
Hi, I'm Urge.
Hi, I'm Chris. Today we will learn about different heat engines.
As we know, heat engines move energy from a hot place to a cold place and divert some of that energy into mechanical energy.
Today, heat engines continue to play a vital role in our society, providing energy to power our homes, vehicles, and machines.
The first law and second law of thermodynamics constrain the operation of a heat engine.
The first law is the application of conservation of energy to the system, and the second sets limits on the possible efficiency of the machine and determines the direction of energy flow.
Did you know that the first recorded heat engine was that made by a hero of Alexander in AD 50?
To further understand about this thing, come and let's discover some things. There are 5 different heat engines, and these are Carnot engine,
Steam engine,
internal combustion engine,
gas turbine,
and Stirling engine. But today we will talk about Carnot engine and steam engine. The Carnot engine is a theoretical heat engine that operates on the principle of reversible thermodynamics and was proposed by Leonard Carnot. It achieves maximum efficiency by extracting heat from a high temperature source, performing work and rejecting the remaining heat to a low temperature sink. The efficiency of the Carnot engine is determined solely by the temperatures of the source and sink, and it serves as a benchmark for comparing the performance of real-world engines. Carnot engines operate through a cycle of 4 steps: isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. The engine utilizes temperature gradients by absorbing heat from a high temperature reservoir during the isothermal expansion, converting a part of it into work during the adiabatic expansion, rejecting the remaining heat to a low temperature reservoir during the isothermal compression, and finally, completing the cycle by undergoing adiabatic compression. The temperature difference between the reservoirs is crucial as it allows for the efficient conversion of heat into work, with the maximum efficiency occurring when the temperature gradient is at its greatest. The Carnot engine serves as an idealized model due to its assumptions, such as perfectly reversible processes, perfectly thermal insulation, and idealized work fluids. These assumptions do not hold in real-world systems, making it impractical to achieve the Carnot efficiency in practice. Additionally, the Carnot engine does not consider factors like friction, heat loss, and practical constraints, which further limits its applicability to real-world engines.
Introduction to Carnot cycle. Carnot cycle is an ideal cycle, is a reversible cycle. The Carnot cycle is a theoretical thermodynamic cycle proposed by Nicholas Sadi Carnot in 1824. Processes of Carnot cycle. The pressure and volume diagram of the Carnot cycle. Process 1 to 2, isothermal expansion, heat is supplied from source at high temperature T1. Process 2 to 3, isentropic expansion, no heat is supplied. However, the work is done by the expense of internal energy. As a result, temperature falls from T1 to T2. Process 3 to 4, isothermal compression, heat is rejected to sink at low temperature T2. Process 4 to 1, isentropic compression, no heat is rejected. Work is done on the system. As a result, the temperature increased from T2 to T1 and the system returned to initial state to complete the cycle.
The first steam engine to be applied industrially was the fire engine, or the miner's friend, designed by Thomas Savery in 1698. This was a pistonless steam pump similar to the one developed by Worcester. Savery made 2 key contributions that greatly improved the practicality of the design. First, In order to allow the water supply to be placed below the engine, he used condensed steam to produce a partial vacuum in the pumping reservoir, which is the barrel in Worcester's example, and using that to pull the water upward. Secondly, in order to rapidly cool the steam to produce the vacuum, he ran cold water over the reservoirs. Savory's engine was a revolutionary method of pumping water which solved problem of mine drainage and made widespread public water supply practical.
The earliest versions of the steam engine date back to Roman Egypt. But it wasn't until advancements in the design by inventors like Thomas Savery and Thomas Newcomen that the power of steam transformed the world. Based on an earlier design by engineer Dennis Poppin, Newcomen's first engine was a piston and cylinder design where the pressure of the steam fills the atmosphere of the chamber and moves the pistons. By the late 1800s, the power from steam-fueled ships and trains accelerated the use of coal and became the world's dominant source of energy. In the early 1900s, electric and internal combustion engines began to outperform the steam engine, and by the 1920s, the ICE had become by far the most popular and dominant of the three. The steam engine was a crucial step in the ongoing search to find the most efficient and clean source of energy to power the world.
So today we'll learn about some of the different heat engines, which are the Carnot engine and the steam engine.
To sum it all up, heat engines are very important in our daily lives as we use energy in our daily living, for example, in our transportation, electricity,
and appliances. So, thank you and I hope you learned something.
Bye-bye!